Okay, we are Project D, Group 4, so we, that is Shantanu, Marcus and Julian. Our topic is the event handling system, and later we will talk about the Twitter sentiment analysis, our project. Yeah, for the event handling system, first reminder of yesterday. In JavaScript, functions are objects. Yeah, there's actually a constructor, but nobody uses this. Usually there's use a declaration, the expression, or you can also leave the name and then have an anonymous function. And today we will use that. Well, it's object, so you can pass it as a reference to other functions in the parameter. So we will use that for callbacks. What are callbacks? Just think of an example in real life. Person A is calling person B and requests to speak Mr. X. Mr. X is not available right now. So person B suggests that person A tells the telephone number, and then when Mr. X is available from the meeting, person B is going to call back person A. So person A can continue to do something else in the meantime. And then later, when the resource is available, so Mr. X, person B is going to call back person A with a given telephone number. So in JavaScript, of course, we don't have telephone numbers, but we have references to functions. So in JavaScript, a callback is basically just a name for a convention to pass a function as a parameter, so the reference to a function, which is then later invoked at some specific point. So when, for example, a resource is available or some specific event, we will take later what it occurs. There are basically two types of callbacks. The synchronous control flow, when the callback is invoked during the blocking function call. So basically when person A calls person B would directly, during the call is active, call back person A, but does not make so much sense in this example. But there's also the asynchronous control flow, which is more important for the event handling system. You can see here, basically, you cannot tell when the callback is going to happen. So basically, the blocking call ends here. Person A hangs up, and then someone later, person B is going to call back. That's a deferred call. So yeah, it's not during the blocking invocation of the original call. Here's an example, a really simple example. So we have a value here. Then a callback function, which we pass to an asynchronous function here. And now the question is here, what will be the value if we run the example? Yeah, please?
Probably undefined. Or
can you run it? Yeah. Can you also explain why?
because the code doesn't wait for the return value.
Exactly. So it doesn't matter in this example, we use set timeout with a timeout of 0. So one could think that it would run immediately, but it's still asynchronous. So just the fact that it's asynchronous makes it, well, run after the code here. We will later see why. So this callback is never, when this function is asynchronous, this code will never run before this part here. So at this point it's undefined, because there's no value here. Yeah, usually you don't have a function here, but you just have an anonymous function in place here. That can lead to problems. If you have a more complex code base, then you might have really deep nesting, and it's really hard to tell here which function is synchronous and which one is asynchronous, and which source, which code runs in which order. Yeah, because you cannot tell if it runs immediately or later. So you can already see here there's a domain called callback hell, and callback hell is what? Callbacks are convenient, but they can be really hard to read. Because first of all, there's a mix of input and output. You use functions, parameters, to pass the input, and also to basically to pass the callback as an output. Then it's hard to tell which is synchronous, which is asynchronous. And also there's a problem with error handling. often you have at least 2 callbacks, one for success, one for failure. So there's also a branching, which makes this even more complex than an example I showed you. And things like try-catch don't work. If you just wrap the whole construct in try-catch, then some code might be asynchronous, and so it's not within the try-catch, and the error will not be catched. So this error propagation does not work either. There's some approaches to avoiding this callback hell. First of all, name your functions and move the definition somewhere else, so you don't have this deep nesting. Well, you still have this deep nesting, but you don't have all the code in place there, so it's a bit more easy to read. Second of all, it has the benefit that if there's something crashing or you're debugging it, you have to name in the stack trace. And later we will see there's a new concept called promises. Not really new, but to JavaScript it's new. We will talk about it later in detail. But for now, Marcus is going to call about the events where we can make use of callbacks.
Yeah, right. Thanks, Julian, for the introduction. It was important to us to lay the technical foundation first because, if you will, functions and callbacks are kind of the secret sauce that JavaScript event handling system is based on. So now that we're definitely on the same page here, let's have a look at our events at the main topic. And by asking ourselves first, what are events? Even. And broadly speaking, events are just actions which can be handled and recognized by software. Furthermore, handling events is an application of the observer pattern you might have heard of already. So you have an object, the subject, which is able to notify its dependent listener functions of specific status changes after they've subscribed to it. And there's really a lot of sources where events may come from. Typical sources are people like you and I, just users, typing keys, clicking on the mouse. You can also set timers to emit events if you want to run your code in intervals. And last but not least, also your program code itself communicates with you using events by throwing exceptions and errors or sending you response messages. So every time you log onto the internet and you visit the website, what you do is you leave a sheer endless trail of events. You open the site, the page is loaded, that's an event. We might as well show you a pop-up already. Or you're hovering over some elements, we can change the style at that point. As you see, there's a huge repertoire of events we can work with in the browser. We can categorize them into, first of all, UI events. That's if you load a page, scroll it, resize it. Key and mouse events, pretty self-explanatory. Then there's also focus events, with which you can tell if somebody is currently focusing an input field, if he's ready to type there. HTML forms got their own events. You can check whether somebody's copying, pasting from it, inputting stuff. And last but not least, the DOM events, with which you can tell if and how the document object model has been modified, for example, by adding or deleting nodes. So, how can we implement it now in JavaScript? I want to show you 4 ways. First of all, there's the HTML attributes, but that's an outdated approach, which is listed here for the sake of completeness. Then there's DOM event handlers, DOM event listeners, that's kind of state of the art right now. And then there's shortcuts that public libraries like jQuery may offer you. So how does it work with HTML attributes? It's admittedly easy. You just specify an onEvent attribute and add it to the element which is supposed to listen for the event. Here we're looking for a click event, so the attribute is onClick. And as a value, we just set the JavaScript code we want to run in that case. Somebody clicks on that button. And here we call the function doIt. So if we click on that button now, what's going to happen? Just click. We can fill a paragraph into that next div segment. We can do that again and again. Doesn't matter, yeah. Click it again, just for the sake of it. Okay, so that's the syntax. It's admittedly easy, but that's also the main problem. Because it's so easy, you're combining structure and behavior, and we don't want to do that. As good coders, that's bad practice. It's furthermore not conform to the principles of unobtrusive JavaScript, meaning you shouldn't force your users to enable JavaScript. It's more like the cherry on top. And also when you're coding in the actual HTML tags yourself, you have to remember the HTML escape characters, which may get annoying quickly. So that's why there's things like DOM event handlers. That's already a lot better because we now separate the logic in a separate JS document. We have that script part here. The process is still the same. First of all, you look for the element which is supposed to listen for the events. So we select it here from the DOM. It's again this button. You specify the event that you're looking out for on click. and the function that you want to run in that case. So we can click the button again. Yeah, this time that happened. Okay, notice how you don't put parentheses after the function here. That's because if you would put parentheses, you'd run it immediately. To prevent that from happening, don't put the parentheses. That's only a problem if you want to pass parameters to the function you're calling, but you can still do that with a short workaround by wrapping it into an anonymous alter function. So, yeah, that's the syntax again. It's a good thing that it's widely supported across browsers, but you still have one big limitation. You can only register one event, one function per event like that. So that's why we also have the DOM event listeners, the most recent approach. The syntax looks slightly more complicated, but is actually still just the same. This time you use the function add event listener, and as the first parameter you specify the event you're looking out for. This time it's just events, not on events, so if you wait for a click, then write click, not on click. Second parameter is the function you want to call without parentheses, and the third is an optional Boolean parameter with which you can change to control the event flow. We're going to talk about that in a second. It's usually set to false. Here it is, by the way, our favorite callback function. Coming for the first time here. So the good things are you can now register as many event handlers as you want to that event. Like that, those handlers work on any DOM element, not just HTML elements, and you can specify, you can change the event flow. You'll see in a minute. There's only one drawback. It doesn't work in Internet Explorer 8 and earlier versions, and Internet Explorer 8 is still at around 8% market share last time I checked, so that's a bit annoying. But you can just use attach event instead of add event listener. Only thing is you can't add that Boolean parameter here for the event flow. What is the event flow anyway? For that I've brought you a graph, a short picture to show you how the browser processes events. So if you click on the link somewhere in a document, here it's a link, first thing that happens, the click isn't registered at the link itself, it's registered at the least specific node, at the DOM root here, the document node. And because it didn't happen there, it then goes on from to its children and grandchildren and so on till it actually reaches the target element. On that way, the first phase, that's called event capturing, our event listeners are usually deaf, so they don't listen, they don't get triggered. But what happens then is you go back up again, all the way back to the root node, and on this way back, that's called the event bubbling phase, you're now triggering the event listeners. What we can do now is, if we add the third parameter to our add event listener function and we set it to true, we tell JavaScript, okay, listen, we don't want our event listeners to be deaf during that phase. We want them to get notified here already, triggered here. So that way you can trigger an element with the same event listener, which is higher up in the hierarchy than the element where the event actually took place. And to show you that, we brought another code example. Please read through it and tell us what's going to happen if we press event bubbling and respectively event capturing, what you expect.
Basically, we are just asking for the order, in which order it is going to print inner and outer.
Yeah. So you have two buttons. They are both wrapped inside an outer element, and both buttons and element have an event listener for clicks, and one uses event bubbling and the other uses event capturing. What do you think is going to happen? Yeah?
At the event bubbling button, there's inner first and outer second, and by the event capturing, it's the other way around.
Yeah, you're totally right. That's what happens. Perfect. So.
Just repeat it for the rest of it.
Sorry?
Just repeat it what happened on the other side.
Yeah, when you press event bubbling, the event listeners are deaf on the way down from the document node first. So even though we have an event listener higher up in the hierarchy, it doesn't get notified at that point. It only gets notified on the way back. That's why we have inner first, The inner element gets triggered first and then the outer elements. Event capturing, it's the other way around. We tell our listeners to already listen when we're going down from the document node, so events higher up in the hierarchy who have the same event listener get triggered first. So, there's a few more ways to specify event handlers. You can also use libraries like jQuery, for example, which internally still use add event listener and attach event, but they offer you a convenient way to code. So you can use the jQuery syntax to select elements here. That's really short. You can specify them with just an on function, or even shorter if you're looking for click events. There's a separate click handler function for that. So it's just meant to be really convenient. If you're using jQuery, go ahead, implement that too, because it's cross-browser compatible. That's what it's for. It's really easy to code. Only drawback is if you're not using jQuery already, then you'd have to implement the whole library, and that seems like a bit of an overkill because you have to get the whole package. There's more tips and tricks to event handling. You can get even more information out of your events using the event object. That's an object that's implicitly passed to your listener functions, even if you don't specify it here in the parentheses. So here we have a listener for our document object to react on mouse move. And even though we don't pass anything as an argument here, we're expecting something to come out here, and that's the event object. So we're listening for a mouse move. If we're moving the mouse around now, we can get additional information from that object. For example, the coordinates which the event took place. So that way you can tell where on the page your user is currently. The event objects also allow you to use events delegating. That's pretty neat if you, for example, have a list of clickable objects. If you have a list and all the list items are supposed to be clickable and supposed to react to something, then you don't want to add an event listener for every single list item. You can just add the event listener for the parent node, for example, the unordered list element. And that way, when you, for example, click on one of the list items, the event flow is going to go down from the document node all the way down to your list item. There's no event listener there, so nothing's going to happen. But then on its way back up, it's going to pass your parent node where the actual event listener is. And there you can get access to the element where the actual event took place with event targets. So that's also very maintainable, because if you add new list elements, you don't have to care about adding new event listeners. The parent node's going to know that. The parent node going to handle that for you. Furthermore, you can influence the default behavior of events with the prevent default method. Let's say you have an HTML form and you don't want it to flash out all the information when somebody clicks submit. You can prevent that default action, then it's going to stay there. And you can even cut off the event flow at that point with the stop propagation method. So that way you stop the event flow from going back up to the document node. Yeah. We also want to talk to you a little bit about Node.js event-driven architecture, because it plays an important role in back-end web development, and because I think a lot of our projects here are also using Node.js. So we also have events there. It's the similar observer pattern. You have emitter objects that create events, and these then call functions, the listeners, synchronously and in order of registration. An example for one of those emitter objects is the net.server object, which emits an event every time a peer connects to it. All those emitter objects are instances of the event emitter class that provides them with methods such as on for registering multiple use event listeners, and once, with which you can specify an event listener just for one occasion. It's worth noting that those events emitter errors kill Node.js processes, so it's good practice to always register an error handler as well to prevent that from happening, so it doesn't kill your code in case something pops up.
Okay, so let's hold on.
Yeah.
So first of all, you said that they use that we're applying here the observer pattern. So please specify what that is for the rest of us.
I think I've specified it at the beginning too. But, sorry?
You had it before?
I had it before, like on the first slide already. But
okay. And then you say that the multi-use on the on event for the event emitter, right? What is the multi-use?
I mean that if you register an event using that method, you can, it's going to listen, the listener function is going to listen to multiple events, so just as many events as you could possibly send that way. But if you register it using the once method, then only the first event gets noticed and listened to, and then it's dead. Okay, all right.
And then the last question is, you're saying that the event emitter actually killed Node.js processes. Why is that?
Errors. So if there's an error coming up in that emitting process, it's going to kill the Node.js process. So that's why you specify an extra event handler.
If you don't catch it.
You basically catch it that way.
Okay. All right. Thanks.
Yeah, we brought a code example just for that. So if you use events in Node.js, you first load the events module from it. It's part of the Node.js core, so you don't have to worry where to get it from. Then you can create new emitting objects using that event emitter constructor. You can create your listener functions that are supposed to do the actual work then. This time you just want to print a classic Shining reference to the console. And afterwards you register your listeners and also your error event handler. Using the on function, here you listen for our event, specifying the listener function. And this is the this is the error handler because we're safe coders. And afterwards you can just emit the event and watch the magic happen. So, now I give back to Julian.
The microphone.
Oh, the microphone. Yeah, you can have it.
Yeah, I'm going to talk about the technical details, how it's implemented, the concurrency model in JavaScript. It's called the event loop. You should be already end of your bachelor's or in your master's already, so I assume that you know what a call stack and the heap is. I'm not going to detail how that works, but in JavaScript, there's a third data structure called the message queue, or sometimes also called the task queue. Where the call stack is for your call frames, so all the local values basically, and the dynamic memory is a heap for global values and some other stuff. There's a message queue which contains messages, and messages contain a callback and some other information, like for example the event object. So just assume that we put a reference to a function and some other data we're not going to talk about in a queue, the message queue, and let's look at an example how it works. So we have here again an on-click handler, then an init function, which calls some other functions. One of them is asynchronous, set timeout is an asynchronous call, and then here we run init. So let's go down here. This is all in the global scope, so this one we don't execute a function yet. This one is just an expression. We don't execute this code either. So we start with init. So let's add it to the stack. Then we're in here, call A. Then maybe during we were in A, someone clicked somewhere on the page. So this event on the button here, so the event handler would be called here. So what happens now is for each event handler, the callback is added to the message queue. So if you had more than one callback, there would be more than one message in the queue now. And so the event handler does not get executed immediately. It just added to the queue, and then we just proceed. This code is not interrupted. This is asynchronous from the actual running code here. So we would proceed with continuing with A, then B, maybe there's another click, and then we're here at set timeout, but this call is now asynchronous. So it's also not run immediately, but instead it's added to the queue, the call to C. So then init is basically done. We're back in the global scope, so we're here. It's also done, and now the call stack is empty. Now it's actual event loop, because what's happening next is we're going to process the next message in the queue. So here it's a click. The callback for this message here is a click, so we proceed with that. Add it to the call stack, and then we're in here. This one could call D. And the call stack is empty again. We process the next queue element, click, and so on. Basically, you see there's you need some external thread running which fills your queue, but the main thread is never interrupted. So to answer the question, is JavaScript single-threaded? Yes, but only from the programmer's view. From the programmer's view, there's one call stack and one thing at a time. Your code is never interrupted. Also, there are no data races. All this filling the queue is external. Like, for example, in Node.js, all the I/O libraries might fill your message queue with some event that your I/O is ready or something. Or in a browser, it might be a user input. While from the programmer's view, there's a single-threaded engine sheet. So, for example, I/O in Node.js is done asynchronous in other threads. And also, browsers, they want to seem responsive, so they want to be rendered like 60 times per second, 60 FPS. So in the case of Firefox, they try to run the render process every 60 milliseconds. And they do that by, well, preferring the rendering function over the normal queue. And also, there's some other exceptions like iframes, so browser windows in your HTML basically have their own runtime. Likewise do web workers. Web workers are basically multi-threading for the web, but it's out of context here. And all these different runtimes can only communicate by messages.
Okay, so I would like to focus on the engines sheet. So we have the I/O, I guess these are blocking operations, right? For instance, if we have to access some resource on our disk, or we want to read off a stream, this is a blocking operation. You're saying that essentially it's going on a different thread, right?
Yeah.
What is the meaning for us in terms of the programmer's view?
From the programmer's view, this is all external from your actual JavaScript. Basically, you just request, give me this resource and notify me when it's done. It doesn't matter if it's done while there's no other code to run, or if it's done in a separate thread. Well, the only effect for you is it's running faster, a lot faster, because it doesn't have to wait until the main thread is empty, and it can run I/O stuff. So, from the programmer's view, nothing is changing, but of course it's beneficial to run it in a different thread. We have more than one core usually.
Essentially, it's not so different than a regular thread in that sense, because we're just waiting for it to essentially come back, right? From just a regular callback.
Again, we can get to your question.
So, how is this different than a regular callback? We're just waiting for a response of this operation. Is that not right?
Yeah, if it's an asynchronous callback, it is basically an asynchronous callback. Mm-hmm. But with events in Node.js, for example, like he said, it's an observer pattern. You can register more than one event handler. But basically, yeah, it's just in a callback which is called asynchronously.
Okay. So essentially, we have to somehow process the result. Right? We have to wait for the result to process it. You guys are going to talk about promises at some point. Right?
Yeah, the promise is the next topic.
Okay.
Yeah.
And now my second question is that it's interesting, by the way, that the browser has a preference for the rendering operations have preferences over the queue. What does that mean in terms of the programmer's view? It doesn't change anything for the programmer's view. That's why they all do it. It's just for the user, so the browser seems responsive. If you move with cursor, for example, this can be rendered. The cursor is not part of the browser, but the user interface stays responsive while events might be just added to the queue and not processed yet. It doesn't change anything from the programmer's view, except that the queue might get longer, but you don't have a view on the queue either. So you just get the events and then you process it. Basically, this whole message queue is not part of the JavaScript specification. It's all what external, a runtime, not the runtime, the runtime environment does for you. The programmer's view is just the runtime itself, which is basically just the call stack. So it doesn't make a difference for the programmer there either. It does not make a difference.
Not really, no.
Okay. All right.
No promises. I already said earlier that we will talk about it as a way to avoid this callback. What are promises? Just think about real life again. If you make a promise to a friend, what states could this promise have? which is a really simple question. What states can a promise have? You make a promise. Let me help you. A promise can be still pending, or it can be. It can be fulfilled. Yeah. And what else? Yeah, basically yes. It can be pending or settled, and by settled we differentiate between fulfilled and rejected. So either we're still waiting for the result, or we got the result, or we will never get the result. Yeah, in terms of programming again, what is a promise? Let's look for the definition on Wikipedia. An object that acts as a proxy for a result that is initially unknown, usually because the computation of its value is yet incomplete. So basically, we have a reference in a variable with a reference somewhere, but this value at the other end is not there yet. And with JavaScript, ECMAScript 6, we get native support for promises, and there's an API which basically notifies us when this value becomes available. So you might already notice there's something similar to events. It's available in all modern browsers. So modern browsers does not include Internet Explorer, obviously, but does include Microsoft Edge. So you can actually use it already. Let's look how it looks like in JavaScript. If you make a promise, you have use this constructor promise and an executor function, which is a function with 2 parameters, a resolve callback and a reject callback. So we might have a function here, an asynchronous function, which immediately returns a promise. So we return a value, but this value is just a reference somewhere where we later get a value. Then we do the actual asynchronous stuff here inside the function from the promise. And later we either return the value by resolving the promise. So we here just pass a string, but you can also pass an object or whatever. And we can reject it. So the error is also optional. So you can also leave it out if you want, but you should include it for debugging purposes, for example. Or if you want to deliver the actual error message here. And then when you want to use a promise, there's prototype then, which also takes 2 callbacks, unfulfilled and unrejected. So if you use this function from earlier, this asynchronous function, we call it. This function returns a promise, and then we can use this then function, which is executed with 2 callbacks, and the callbacks are executed when the value is available, or if it will never be available in case of an unrejected. So we can then just print the result or print an error. Of course, there's more to the promise concept, because with that we cannot do that much. But for example, we can chain promises. Since unrejected is the second callback, second parameter, we can also skip it. And then this one would be undefined. So we can just pass 1 callback here, which is on what was the name? Unfulfilled, yeah. So we could then we can here in this callback function again return a promise, and then basically this part also returns a promise. So we can chain another then handler there, and we can do it of course as often as we want, as long as we return a promise. So we just need to return a result, and it's immediately a promise again. I know you might say, but we skipped the unrejected part, so we don't handle the error yet. We can do it by using the catch method, which also catches exceptions. So unlike this whole callback where you cannot use try catch, this catch here actually also catches exceptions, since all this is run after each other. So at first this is run, then this, then this, and this. So if you have a catch here, it can also catch all the asynchronous exceptions, which occur during asynchronous code execution. Now you might wonder what this catch function is. It's actually just syntactic sugar. It's a shortcut for then undefined function. So what happens is JavaScript passes down the error from one handler to the next until there's one handler for the failure case or redirected case. With that, yeah, the question?
What happens if the error happens in the first promise? Like it executes other promises too, or just
yeah, then we return a promise again, and this error is passed down until we are here in the catch part.
Okay, so it's do all the promises and then goes to the error part.
Yeah, we return well, if there's an error already here, we will never call this part, but it goes around.
In the first then,
yeah.
If an error happens,
yeah, then we return a new promise here, and then it's also passed down. So whenever this error occurs, we can handle it in the last part here. So it simplifies the error handling a lot. We can do this normal error propagation. Yeah, it's really convenient. But we can actually do more. We can combine promises. So here there's an all method. With that we can combine an array of promises into one. And this returns the new promise, the combined promise. On that we can call the then function again, and we handle then an array of results. So what we can do, for example, we have an array of items. Maybe we want to read a list of files, or we want to insert a list of items to a database. So we want to run a function on each of these items. And for that, we have a function which returns a promise, the async function. And this promise, we push it onto an array. And then we combine all these promises into one promise, which we then handle with the then function. So in, for example, if we load a list of files, in case everything went fine, we would be here then, when everything is done. So it waits for all the promises. It's like a semaphore or a wait group in other programming languages, this part there. And we can then handle, so all the loading would be in different branches, basically asynchronously. But here we can synchronize all the branches again to one point and just continue with all the results available. It's also really another convenience, because otherwise with all these different branches for different callbacks, you have so many, well, threads, not really threads, but control flows. It's really hard to handle sometimes and to combine them back. And this proxies is, these promises are really convenient. They only can succeed or fail once. So if the value is available, it's available forever. You cannot have another value then. Also, there's no timing issue with event handlers. If an image, you want to call, for example, an onload function on an image, and you register this onload callback after the image is already loaded, then this event is of course never triggered, because it's already loaded, so there's no point in triggering another event for it. And with promises, if the value is already available and then you register a new handler, it will immediately call the then part, so there's no timing issue. You have this user top-down flow. If you remember the example, we just chain another then handler. There's no deep nesting, there's no different branches of control flow, and you have a separation of input and output, since you just return a promise and don't have to pay so many event handlers there. And also there's many lists of benefits, but no really flaws. New APIs, asynchronous APIs in JavaScript will use it, and some out will be updated, so it's might be a good idea to understand this concept and start using it. Yeah, please.
Is promise is something that is in JavaScript already, or is this like what, E6 or what?
Yeah, I just said earlier it's part of ECMAScript 6, but it's already available in most browsers, and I think it's also available then in Node.js, because Node.js is just V8.
And jQuery. And jQuery.
Yeah, there's a different libraries which also implemented, but jQuery is a bit different from this API.
I think like Angular implements their own.
Yeah, Angular, and there's a lot of libraries, so there's some polyfills if you don't want to use ECMAScript 6 yet. But most of them behave a little different. Yeah, but now Shantanu is going to talk about the Twitter analysis. So
okay, before we go into that, any questions about the presentation so far?
Please.
Do you think it's possible to create a web application without any use of events?
Okay.
Do you think it is possible to create a web application without any usage of events?
Client side or server side?
Client side.
Probably not, because you cannot react to user input then, for example. Or you can also not do any I/O, because all this I/O is for the reason that you don't want your functions to be blocking is all asynchronous. So maybe you can basically do nothing.
And so can you go back to slide 28, please?
28.
That was, I guess, the most confusing part. Yes. Can you please explain again? So browser rendering part has preference of view, right?
I should have done it all right.
Rendering. What exactly do you mean by rendering? As in rendering of just canvas elements?
For example, yes. Canvas could be rendered, so in JavaScript there's also a method called request animation, something famously. That's synchronized with the render. But mainly just redrawing the user interface. So if you hold
the whole DOM?
No, it's not the whole layout which is built again. The DOM is only modified if you make a change shape, but the rendering is just repainting it basically. So you want 60 frames per second, and for example, then you would run it every 60 milliseconds to get 60 FPS per second. So for example, if you hover an element, it would not be really a change to the DOM, it's just change the color, so you only have to change one element. That would, for example, be some of this difference.
And slide 36.
36?
So can you explain again what exactly do you mean only succeed or fail once?
Yeah, basically if a reference to one slot, and the slot is not filled yet, and it only gets filled once. So if there's unlike events where the event handler can be triggered multiple times, except for Node.js, which is once method, then your callback might be called arbitrary times, like 1,000 times. If you click a button 1,000 times, this one click handler might be called 1,000 times. But if you have this then function on one promise, so it's bound to one specific value, so it's only called once. And also, if this value is already available, it's called immediately, otherwise it waits until this value becomes available or fails.
So in other words, each on-click event, for example, on-click event would create just one promise, right?
Yeah, so if you have an on-click event, you could return a promise to it. Yeah, you can wrap all this event stuff in promises. That's also what they will do. Try to do later with updating these APIs, asynchronous APIs. Yeah, basically for every event call you would return a promise, and that's bound to one specific call basically. Other questions? Project or?
Yeah,
I just like, do you think you can implement a whole problem without listening?
Yeah, sure.
Why?
For example, if you're listening on a pause or like, I don't know, you implement a web key or tweets and you display whatever is new.
No, but let's think in 1950s. You can just put the function inside HTML. So yes, you can.
What?
You can. Technically speaking, you can, without event listeners. So, yes.
You can just display static HTML, but it's...
Exactly. You can just put the function inside the button. Like if you have a button element in the HTML.
But it's basically also event handling.
It's not direct event listening. It's more like
See,
do this if I click there, which is not really an event in per se.
Yes, better definition.
Still be dispatched.
Yes, but the code is like not bound to that element by an event listener. It's bound to that element by the code itself.
So hello everyone. So today I'm going to give you a brief introduction, a brief overview of our project. So we are group D. So our project is basically Twitter sentiment analysis. So first of all, let me give you a little bit of information about like the team members. So myself, Shantanu, and Marcus, we both are basically beginners in JavaScript and Git also. And all three of us are beginners in Node.js and MongoDB. Regarding the work distribution, first of all, we segregated our project tasks into 3 separate tasks. And as I have already mentioned that myself and Marcus, we are like beginners in JavaScript. So initially, first we chose whichever topic like we are comfortable with, and like the rest of the part is done by Julian. Yeah, so I opted for the Twitter API part, and Marcus chose the visualization part. And Julian is like all around, he's like everything. Yeah, combining everything, the whole project setup, everything.
So wait, you're a beginner in JavaScript and you became a guru at the same time?
What?
You're a beginner in JavaScript and you became an all-around code guru?
No, he's not. Like,
oh, you are?
Yeah, yeah.
Okay.
Yeah. So like the basic approach for our project, first we had to fetch the data which is like provided by project A. So like Game of Thrones characters and the episode details. Next step is run all the characters on Twitter and get the related tweets and save all the data in MongoDB. Next, for every tweet, we run a sentiment analysis on tweets. So for the people who have never heard the term sentiment, it is basically the viewer's attitude towards some particular event or some particular character or some particular topic. So basically we are using the retext sentiment package which is available, and it basically, what we do, as an input we provide the Twitter string, and it returns us some number which is basically in a number range from -6 to +6. So +6 is the positive response, and -6 is the negative response, and 0 is neutral. So that's how we calculate the sentiment of every string, and we also save that in our database. So what our project will basically offer is, it will calculate the sentiment analysis, and it will say that which one is the most popular character after airing of a latest episode, and also will provide one CSV data per character which will be having the date and the negative response and the positive response and the overall popularity of that character, and it will be based on like the episode airing dates. Next, so all the analysis and everything, the visualization part we will be doing using the D3.js. Yeah, so the main application structure which we are following is, all you know is MVC structure. So models, which is basically for the database interaction, and view, which is the HTML template and used for the visualization part. And the controller is basically which handles the requests, and it helps to interact between the model and view. Also along with that we have the crawler part, which is basically the API that is provided by project A, and also we have Twitter. So in Twitter API we are using both REST API and streaming API. The REST API is used to search the old tweets, and the streaming API we are using to fetch the new tweets or the recent tweets based on the particular string that we are subscribed to. So during our project analysis we have found out some issues for Twitter API. Like the first one is the search API does not provide tweets older than a week. So initially we thought that we will collect all the tweets since 2011, but then we found out that it is not possible, because Twitter API does only provide a week older tweets. If we want to search 2 weeks older tweet, it returns nothing. So that is a limitation, and there is another limitation which is a 15 minutes window is there. So in a 15 minutes window we can only send 180 requests, and in each request we can maximum get 100 tweets. So it makes in 15 minutes we can only get 18,000 tweets. So in any case, suppose in 5 minutes you already have received 18,000 tweets. So in that case 10 more minutes you have to wait, and then again we can resend a new request for the new tweet. So that is the limitation which we found out. So now our approach after that limitation is like,
for both the REST and the streaming?
Yeah, no, but this is for only the REST, like old tweets.
Okay.
Yeah. So now our approach is basically to get as much as data possible, but we know that not much as possible, because 7 days limitation, and we are using the streaming API to get the updates, latest tweets. Yeah, the visualization, I would request Marcus to just explain.
Okay, so we brought you the main chart that's going to show the sentiment for a character. So basically we just had the calculated sentiment metric. Sorry?
Microphone.
Oh, yeah. Yes.
Actually, this is live, so this is actually rendered in DS3.js now.
Yeah. So
it's not a screenshot.
yeah, so that's just that's the main window where you can see your character's popularity. On the y-axis you have the calculated sentiment metric. On the x-axis you have the date range you're looking at. We thought it's nice to display both the hatred and the love for a character, so that's why we're basically plotting two lines. So we're showing you the positive sentiment and the negative sentiment and not just adding it up.
Is that a specific character?
That's
Maybe a single function plus some random spice there.
Yeah, so what's still missing is we want to show a list next to it where you can pick the most popular characters from it, so you don't have to search for them. There's also a search bar where you can type in character names to get the others. And we want to make the graph scrollable, that you can select the date range like that. And also, what's a little bit harder is zoomable. So best case scenario, you can zoom into a day and maybe also see how a character's sentiment was changed during an episode, like during certain events. Yeah.
Are you going to highlight those events?
Yeah.
Series?
Events, I don't know, definitely the episode airing dates, events. I don't know yet. Haven't thought about it actually. Yeah.
Oh, I mean the episode's airing is an event.
Yeah. But not like Joffrey gets killed at minute 15. Like okay.
I have one question.
Yeah.
Maybe I missed it. I don't entirely understand what the graph is about. Like what the scale is about.
Yeah, that's the metric. Like our calculated sentiment metric. Okay. So that's based on the tweets, the calculations we do.
But is there some explanation of this metric somewhere?
And not yet, we're thinking about it. For example, we don't just want to take the tweets and put them here on that axis because, for example, a tweet with 1,000 retweets should have a higher impact on our scale.
There's clustering algorithms for that, just so you know that. Clustering.
I'm not doing that.
Your partner.
Okay.
I was thinking about this also yesterday to group. I don't remember the one with that they have to calculate the probability that a character dies.
Yeah.
Basically, you can use the same clustering algorithms. Some groups. Just
okay.
Okay. Yeah. Great. Sounds great. Yeah. Then we have to display the trend maybe in the separate bar chart where you can see how the popularity in that date range was affected compared to the overall popularity of the show or overall popularity of the characters. So
how do you set y0? Like how do you set the starting point? Because essentially everything is in relations to
y0 is
neutral sentiment, right?
Yeah, y0 is no interaction. Like y0 is no interaction, no tweet.
No tweet.
Yeah.
Also, you're just counting number of, but then you count.
No, we're counting the number of tweet. Yeah, and we're like, for example, it's not implemented yet, but we want to like add factors for number of retweets, stuff like that.
So there's no metric of like that actually compares positive versus negative. We don't know if the current is positive or negative, right?
I don't get it. I don't get it.
So we want to know if a character is now becoming more popular or less popular.
Mm-hmm.
Not just like the negative and the positive number. Like we want to know if it's actually trending to the positive side or trending to the negative side.
Yeah, that's what I meant with adding a separate bar chart for that, but actually you can also already tell from that chart. I cannot see it now, but just a second.
Right, we're gonna go a little bit over.
Yeah, I mean it's implied in that chart. Basically, if you look at it, you see that it's going downhill for that character, but still we want to add a separate chart for that, you're right.
This is one character, right?
Yeah, this is one
character. There will also be a function to compare characters later.
Yeah.
You don't have to change the color, so like maybe positive is dark and negative is light or other way around, and then just be different color.
we're a bit over time. Where are you standing in with this right now? I mean, what do we have so far?
We have the fetching tweets part. We have the visualization. This is more or less current, but Marcus is working on another step there.
Yeah.
And well, we have the base app running. So, but for now we are just returning fake data because we don't have this a lot of tweets we can analyze yet. Also, there's a problem that we don't have many. There was a problem that we couldn't get a list of all episodes or characters yet.
Okay.
So, but now, next few days, I guess we will start compiling it into
Are we going to have
live
a demo?
What?
Are we going to have a live demo that we can see, or that's just through, or you want to have a live demo?
No?
No. Now I guess if you don't have it, but
yeah, we can do it sometimes.
Yeah, you have something?
No, not yet, but this is basically our live demo. It's just fake data, and if you refresh it.
We want to have a live demo. Well, we want to have a link where we can actually.
Okay. Yeah, but if you
What do you do?
refresh it, you should see it's different generated data. So this visualization part so far works, but yeah, you just still have to combine it.
What we mean by live demo is the capability to access real data.
Yeah.
Not fake data, and actually being able to search for characters and episodes and stuff like that.
Yep.
Okay, good. Thank you so much. Okay, one last question and then we move on.
I think you said about the streaming API that it does not have any limit, but I think it does. It automatically throttles to be like about 160 requests per 50